everyone, and welcome to this lesson. I hope that you're going to learn quite a bit in this lesson, especially if you're in grade 12, because we are going to be looking at Term 1 revision. Now, it isn't possible to do absolutely every single concept that you learned in Term 1, so we're just going to look at some of the key concepts and just focus on revising those and make sure that you understand those quite well. So in today's lesson, we're going to be looking at sequences and series. We will also have a look at finance and then do a bit of trigonometry as well. And what I'd like to kick things off with is just for you guys to now take a few minutes and to summarize the key points when we're talking about arithmetic sequences, quadratic sequences, geometric sequences, and sum to infinity. So there's quite a lot of information when you look at each of these sections. So try and get all the key points while you summarize this let's give you 3 minutes because there is quite a bit to do. All right, guys, so you have quite a lot of time there just to think about all these different concepts and to list some of the key points. Now, if you are revising for a test and exams, this is a good point where you want to get your books out and you want to actually make notes because we're going to go through and quickly summarize all the key points from these different types of sequences that you have dealt with. So get your notebooks out, get your pen out, and start writing. Okay, so let's first talk about an arithmetic sequence. In an arithmetic sequence, remember, you're going to be talking about sequences where you start with term 1, term 2, term 3, and so on. Okay? The important thing to remember about an arithmetic sequence is that there's always a common difference, which we call D, between the consecutive terms. Now, D is the difference between any two consecutive terms. So it's Tn minus Tn minus 1. So what that means, for example, if Tn is term 3, then term Tn minus 1 would be the preceding one, the one just before it. So it would be term 2. So the difference you will get by saying term 3 minus term 2. And if it's an arithmetic sequence, the difference between each and every consecutive term will be the same. Okay? The general form, so we know that term 1, we say, is equal to A. All right, the next term, if I want to get to the next term and I know the common difference between the two terms, I simply take A and I add D, and we continue in this fashion so that you can see what the general form is for your arithmetic sequence. The formula that you use to find a general term is Tn is equal to A plus n minus 1D. And if you were to graph an arithmetic sequence, it would lie on a straight line. So it's a linear number pattern. Okay, then I asked you to talk about quadratic sequences. Now, what you need to remember in a quadratic sequence is that there isn't a constant first difference. When you're dealing with quadratic sequences, what we're looking at is a constant second difference between any two consecutive terms. The general formula you will use to find any term, Tn is an squared plus bn plus c, and if we had to graph the sequence, it would lie on a parabola, because remember, all patterns can be represented by graphs. Now let's talk about geometric sequences. In a geometric sequence, we know that there's a constant ratio between any two consecutive terms. So you've got term 1, term 2, term 3. If I want to find the ratio, all I do is I take the consecutive terms and divide them, because ratio, remember, you're talking about a fraction. So term 3 divided by term 2 will give me the same answer as term 2 divided by term 1. The general form, you get your first term being A, and then to get from one term to the next term, what do? You have to multiply by your constant ratio. So you'll see that term 2 can also be written as the first term times r. Term 3 can be written as the first term times r, so times r squared. The general formula you use for a geometric sequence, Tn is equal to A times your ratio to the power n minus 1. And if you had to graph this sequence, it would lie on an exponential curve. Now, this is something that sometimes we use interchangeably, and it isn't correct, but I often will hear learners saying sequence or series, arithmetic sequence. They're technically not the same thing. Whenever we're talking about a series, we're talking about adding things together. So that leads us to the next point. When we're looking at the sum of certain numbers of terms in a sequence, we're going to look at each of them separately. So first, let's start with an arithmetic series. So we're talking about one that forms a linear number pattern. We've got Sn, which is your sum formula, is equal to n over 2, where n is your number of terms, a is your first term, and l is your last term. So if you are given the last term in your series, you can then use that formula. Okay, and then you also have the second formula where if you're not given your last term, you can use that one. And then in your geometric series, those are the two formulae that you are given, and you will see that if r is less than 1, you need to use the first formula where 1 minus r is in the denominator. If r is greater than 1, we use r minus 1 in the denominator. Okay. And then the last point I asked you to just make a few summaries, notes about, is sum to infinity. Now, sum to infinity you will only get when you have a convergent geometric series. The series will only converge. Now, when we're talking about a convergent series, what we're talking about is you've got a geometric series, and as you're finding the sum to infinity of your number of terms, it converges. In other words, it tends to a specific number. There is a limit to which this series will converge. So there's some sort of number that the series converges to. So that's what we're talking about here. Now, your geometric series doesn't only converge, it can also diverge. How do you decide? Well, if your ratio R is between the numbers -1 and 1, then you are dealing with a convergent geometric series. So it will tend to a certain fixed number as the number of terms in the sum tends to infinity. And obviously this is the formula that you use for sum to infinity. So your test is, if R is between -1 and 1, you're going to get a convergent series. If R is outside of that range, then you're going to get a divergent series. So it's not going to tend to a certain fixed number. All right, so that's quite a lot of information for you to take on board. And I think what we need to do now is go straight into doing an example, a question with to deal with a convergent geometric series, because it is a question that a lot of learners struggle with just because they simply don't understand the concept of a convergent and divergent series. So I want to talk a little bit more about that. And what I want to do now is just give you some time really to take this question down. You're not going to have enough time to complete the question, but I want you to take the question down so that we can come back and do it together. So I'm going to give you just 2 minutes to take this down. Right, guys, so in this question, we were dealing with a convergent geometric series. And I said to you, you're not going to have time to actually do the entire question, but I want to give you a chance to do it. So what we're going to do is take a quick break, so you'll have a little bit more time to look at the question, and then we'll come back and go over it together. Welcome back. So remember, in today's lesson, we are looking at Term 1 revision, and we started today's lesson off by looking and summarizing the key points about arithmetic and geometric sequences, quadratic sequences. We also touched on sum to infinity, and we looked a bit at series as well. Now remember, when you're talking about sum to infinity, you're talking about a geometric series that converges. Now converges, when you think about the word converge, it sort of comes to an end, or it not really comes to an end, but it reaches a certain point, a limit, right? And when you're talking about a convergent geometric series, you're talking about a series that tends to a specific number as the number of terms tends to infinity. And what I showed you in the beginning, in order for that to happen, your ratio has to lie between -1 and 1. Otherwise, we say the series is divergent, which means it doesn't tend to any specific number. The important thing you also need to remember is that an arithmetic series will never converge. It will either tend to positive or negative infinity. So an arithmetic series does not converge. So this is only the sum to infinity. We're only dealing with geometric series. Okay, let's get to the first question I gave you. So you were given the first three terms of a convergent geometric series, and you had to calculate the value of x. Well, because we know it's geometric, that's the first clue to you that there is a constant ratio. So term 3 divided by term 2 is the same as term 2 divided by term 1. That's the only bit of information really that you can use here because you've got your first three terms. All right? So if I'm looking for the value of x, I need an equation. Where do I get my equation from? There we go. That's where we're going to get our equation from. I can say term 3, which is 2x minus 5, divided by term 2, which is x minus 1, is equal to term 2, x minus 1, divided by term 1, x plus 1. Hence, we've got an equation which we can now solve for x. So the easiest way to do this, yes, you can find an LCD, but I prefer to just use the method of cross-multiplying. So we're going to have, which is essentially the same as finding an LCD, just in case you were wondering. So we're going to say 2x minus 5 in the numerator on the left times your denominator x plus 1, okay, cross-multiply, is equal to x minus 1 numerator on the right times denominator on the left, which is also x minus 1. Okay, so let's quickly square this out and see what we get. So we're going to get 2x squared, and I've got minus 5x plus 2x, which gives me minus 3x minus 5 is equal to x squared minus 2x plus 1 by foiling out both brackets. Okay, so we're expanding both brackets. Bring everything over to the left-hand side. I'm going to do this all in one step just to save time. So I'm taking everything over to the left-hand side and changing my signs. 2x squared minus x squared is just going to give me x squared. Minus 3x plus 2x is going to give me minus x. And minus 5 minus 1, remember when you take over to the other side of the equation, your signs change. So I get minus 6 is equal to 0. You can then factorize that. So it's x minus 3 times x plus 2. If you're getting stuck at this stage, it means that you need to go back and revise your trinomials from grade 10. Okay, so we factorize that into x minus 3 times x plus 2 is equal to 0. So therefore you get two values for x. X is equal to 3 or x is equal to minus 2. Now, I just want to go back and show you in the question here, they said that x cannot be, or x is not equal to minus 1 or 1. And the reason for that, as you see in your equation, when we set it up, you've got an x plus 1 and an x minus 1 in the denominator. So, if x were to take on either the value of minus 1 or 1, it would mean your denominators would be undefined. Hence, those values are excluded. So now we've got two values to choose from. Which do we choose? We've got x is 3 or x is minus 2. Now, this is where you've got to be careful because remember, you're looking for a convergent series, which means your ratio has to be between minus 1 and 1. So you want to choose the value for x that's going to give you a ratio between those two values. So you substitute your x values back into your first three terms and then see what you get. So if I substitute x is equal to 3 into my first term, which is x plus 1, I'm going to get 4. Okay, I'm substituting x is equal to 3 into, remember your first three terms were x plus 1, x minus 1, and 2x minus 5. So if I put in x is equal to 3 in the first term, I get 4. X is equal to 3 in the second term, I get 2. And then x is equal to 3 in the third term, we're going to get 3 times 2 is 6. 6 minus 5 is 1. When you try and find your ratio between these terms, so 1 over 2, you're going to get a half. All right, so you can add, so when we put the 3 in, we've got 4, we've got 2, and we've got 1. So I know that I'm going to get a ratio of a half. You then look at a half and you say, well, is it less than 1? Yes. Is it greater than minus 1? Yes. So therefore, it is a ratio that lies in that interval. So therefore, you will have a convergent series. We do the same thing with the other x value, which is x is equal to minus 2. So if we put minus 2 in place of our x values, let's see what we get. So in the first term, minus 2 plus 1, that's going to give me minus 2 plus 1 is minus 1. Okay, I'm simply substituting the x values in that expression, those expressions there. So when x is minus 2, I'm taking that and I'm putting it in place of x. Minus 2 plus 1 gives me minus 1. Minus 2 minus 1 is going to give me minus 3. And then we've got minus 2 times 2 is minus 4. Minus 4 minus 5 is minus 9. You then test your ratio. So if I go minus 9 divided by minus 3, what do I get? 9 divided by 3? 3. Minus divided by minus, plus. Then if I do term 2 divided by term 1, minus 3 divided by minus 1, I get 3. You now look and say, okay, is this, so don't just blindly choose your answers, this 3, does it fall in your ratio less than 1, greater than minus 1? No. Fails on both sides. So therefore, when x is equal to minus 2 is not a possible solution here because we are looking for a convergent geometric series. So therefore, my answer here is x is equal to 3, and that's going to give me the ratios 4, 2, 1. That's going to give me, the first 3 terms, 4, 2, 1, and the ratio of a half. Okay, so that's what we're going to use. So to answer part calculate the value of x for a convergent geometric series, well, your answer is just going to be x is equal to 3. All right, part B, calculate the sum to infinity. Now remember, sum to infinity, you're looking for what value your geometric series converges to. So you have a formula to help you. You've got this formula. Your sum to infinity is equal to a over 1 minus r, and remember your restriction on r. Okay, so we've got values that fit within that interval. And I'm using the numbers 4, 2, 1. A is my first term, and r is my ratio. All right? So therefore, I substitute into my formula. I get a has the value of 4, and r, we know the ratio. We said term 3 divided by term 2, and we got a half. So I substitute that in. So I get 4 divided by 1 minus a half, which is a half. 4 divided by a half, which is the same as 4 times 2 over 1 if you tips and times, but you can do that on your calculator as well, and you get an answer of 8. So the sum to infinity converges to a value of 8 as your geometric series tends to infinity. Okay. All right. Okay, guys, so that's really, we went into quite a lot of detail there, and I hope that you really understand now how to deal with sum to infinity. I want to move on to our next topic, which we discussed, and that was, which we said actually that we're going to discuss, which is finance. Okay, one of the other big ones that you did in the first term. And I want to once again give you a chance to have a look at summarizing these few key points. Tell me what formulae are used for each of those different types of calculations, and also tell me what an annuity is and give examples. So here we will give you 3 minutes again. Okay, guys, so let's go through each of those different formulae that you use and also look at a little bit more information about each of those different types of formulae you use and just discuss a little bit more what each of those are about. And this is a good point again for you to make notes if you are summarizing and if you are learning for tests. Okay, so simple interest we know pays the same amount of interest every year. And we also call this a flat rate. It is fixed, it is non-growing return, and it really is the most basic type of return, and therefore it's got a basic formula where A is equal to P times 1 plus I times N. Let's go through each of those letters. A stands for your final amount, or your accumulated amount. P is your principal or your initial amount. I is your interest rate. And N is your period. Now, generally, when you are dealing with simple interest, you will notice that you're always dealing with yearly interest rates, and your period should also be in years. Now, the more complicated one we deal with, which we use a lot more in terms of how we would like our money to grow, and that is compound interest. So compound growth means your interest earns interest. So what happens is that you make money faster. And if we had to graph compound growth, you will see that it would resemble an exponential curve. The formula you use, A is equal to P times 1 plus I to the N. The letters still mean the same thing as previously. What you need to remember, though, very importantly when you're dealing with compound interest, is that your interest rate per unit time needs to match your period, your compounding period. So, for example, say your interest is calculated on a monthly basis, then your period needs to also be monthly. Okay. All right, we also then looked at what is simple depreciation. Well, you had to look and tell me what is the formula. That's the formula that we use. A is equal to P times 1 minus I times N, and that's also an indication to you that you're dealing with depreciation. We also call this straight line depreciation. Compound depreciation, A is equal to P times 1 minus I to the N. So I quickly want to go on to what is an annuity. Now that we've discussed all the formulae that you needed to use for finance, what is an annuity? Okay, that's the next set of formulae that we need for finance. And an annuity, remember, is a series of equal payments at regular intervals. Now, I also said to you, well, give examples. Where do you use that? And really, the times that you've looked at is when you were working out the future value, and that's when you were dealing with investments. And then you also looked at times where you're dealing with the present value formula, and that's when you were looking at loans. So those are the two different times that you guys have experience using these formulae. These annuity formulae. So the future value of an annuity measures how much you would have in the future given a specified rate of return. So the formula you use is as is on your screen. F stands for your future value. X is your payment per period. So that's your payment. I is your interest rate. And N again is your period. And remember, these two always need to match. Okay, the present value, and that's when we're looking really at loans, the present value of annuity is the current, or another word for current, present value of a set of cash flows. And you are given, again, a specified rate of return, and that is the formula that you will use once again on your screen. P is equal to X times 1 minus 1 plus I to the negative N, indicating that we're bringing cash flows backwards. And P stands for your present value. Okay, so it obviously makes sense now to do questions based on what we've done so far, something that you come across quite a lot in grade 12 is sinking funds, okay? And I hope you don't get that sinking feeling when you hear the word sinking fund, because it isn't as complicated as it sounds, but I know that when you're faced with those examples, there's so much of information that it sometimes is overwhelming. So we want to break that down by going through a question, and I'm going to do that with you after this break. Welcome back, everyone. Remember, in today's lesson, we are doing Term 1 revision. We've already looked at sequences and series, and then just before the break, we talked a little bit about finance, and now it's time for us to practice our finance by doing a sinking fund example. So I'm going to give you 3 minutes here, really just to take the question down. It's impossible to do this question in 3 minutes. So I know it's not enough time to do the question, but I want you to take the question down so that you can follow with me as we go through this. Also, when you're taking down the question, mark off the key points that you need and the key things you need to remember from the information that's given to you. So you've got 3 minutes to have a look at this question. Right, everyone. So hopefully you've had time now to take down that question and to highlight, well, they've already been highlighted for you, but those key points that you need. Now, let's talk a little bit about what a sinking fund is before we start doing this question. Now, you know that if you buy a cell phone, for example, and you've saved up and you've got enough money and you've bought this latest cell phone that you really, really love, but immediately from the time you start using it, what happens to it? It starts losing value. So say you bought the cell phone for 17,000 Rand. Well, maybe not you, maybe your parents bought the cell phone for 17,000 Rand, and they've now put it in their pockets, they've walked out the store, they start dialing people, immediately it starts losing value. So what we're saying is through usage, items lose value, and that's what we call depreciation. Now you can imagine for something like a cell phone. So you bought your latest cell phone, you want to sell it a year later, you're not going to get the same amount of money for the cell phone that you have sold, and that's due to depreciation. But you can imagine for businesses on a much larger scale, items are going to lose a lot of value, and those items will need to be replaced. So for example, equipment, cars, and that kind of thing, when they lose value, businesses already start thinking, well, how are we going to replace that item when we can no longer use it? So what they set up is what we call a sinking fund. So a sinking fund is where they will make regular deposits and sometimes lump sums, so that when an item needs to be replaced, they already have money saved in order to replace the item. So that's what a sinking fund is. Now let's have a look at this classroom situation with Winfield School. They need to replace a number of old classroom desks in 6 years' time. So we take note of the period. The principal has calculated that the desks are going to cost 44,500 Rand. So that's the amount they're going to need in 6 years' time. The school establishes a sinking fund to pay for the new desk. So they've already decided, well, we need to start saving so that we can pay. And immediately deposits an amount of 6,300 Rand into the fund, which accrues interest at a rate of 6.85% per annum, compounded monthly. Now straight away when I look at this, as you see, I've highlighted key points for you, but also I notice that the interest rate is compounded monthly, but I am saving over a period of years, okay? So that already tells me, well, hang on, something there doesn't match. I need to make my number of years match the compounding interest period, okay? So we need to change years 2 months when we get to that point. But let's further break down the question, right? They say, how much money should the school save every month so that the sinking fund will have enough money to cover the cost of the desks? Okay, so there's two things happening here. We're taking 6,300 Rand, we are immediately putting it into a fund, and that's going to accrue interest, right? But then there must be some sort of shortfall, hey, because they say how much must they save every month so that they will have enough money. How are we going to find out what that is? So let's set this up. All right. In the first case, you've got 6,300 Rand that's being deposited right now. It's going to grow over a period of 6 years to some amount. And using my compound interest formula, I will be able to determine what that amount is. Because the question asks you how much money they're going to have to save every month, you can thereby assume, or therefore assume, that that amount is not going to be 44,500 Rand. Otherwise, we wouldn't need to deposit more money in. So how do we find out what the value of this deposit is going to be? Well, we use our compound interest formula. We know that we're starting with an initial value of 6,300 Rand. Then remember, your interest rate and your compounding period need to correspond. So because your interest rate was given to you in terms of months, it's 6.85% per annum compounded monthly. So if I want to find out what the monthly rate is, I'm going to say 0.0685. So that's your 6.85% divided, okay? And then you're going to divide by 12. Right. Your number, your period, your N, also needs to match that. So we know that we're dealing with 6 years. How many months do I have in 6 years? 6 times 12, and that's going to give you 72. All right, so I'm going to have my 6,300. I want to find out what this is going to amount to. What is it going to accumulate to? My interest rate, I'm going to put that in straight away, 0.0685 over 12 raised to the power of 72. Okay, you put all of that into your calculator, all right, and you're going to get a value of 9,491.35. And guys, I'm not going to show you at this point how to use your calculator because that's a pretty straightforward calculation. And I'm sure that a lot of you, well, most of you, all of you, will be able to plug those values into your calculator. We will go over the calculator steps when we're looking at those future value, those payments that we need to make, those monthly payments. Okay, so this is a straightforward put into your calculator, plug and play. All right, now, so we know that this amount of 6,300 grows to 9,491 Rand and 35 cents. But there's a shortfall because we needed 44,500, and this is where we're going to now be able to work out what those monthly payments need to be. Okay, so what do? We say, okay, I know that, and you can use a timeline again to set this up, okay? And this is going to be going on for, we've got monthly payments, and those are happening for 72 months, all right? And we know that at time 1, we're trying to work out how much are we putting in. How much are we putting in each month for 72 months? We know that we need to work out how much we're going to need at that point in time. So after 6 years, the deposit we know is worth 9,491 Rand and 35 cents. So that's after our 6 years. So the balance required in the sinking fund is going to be 44,500, which is the value of the replacement of those desks, minus how much we've saved in 6 years. And that's going to tell me how much I need to work towards saving. And let's see what we get. So 44,500 minus 9,491 Rand. You put that into your calculator and you get 35,008 Rand and 65 cents. Okay, so that's how much the future value is that you now need to accumulate. So you need to put money into this account on a monthly basis so that it adds up to this 35,000 Rand amount, so that when you add everything together in your sinking fund, you then have enough money to pay for these desks that cost 44,500, okay? So I know now that that is what the future value is. That's what I need to save towards. Okay. So that's the amount that's sitting here. That's 35,008.65. Okay, what is X? So remember this formula, it has 4 variables. If you know any of those 3, you can calculate the other one. So we're going to have X into 1 plus I. Our interest rate that we're using is still the same. So it's 1 plus 0.0685 over 12 raised to the power 72, so it's still over 6 years, minus 1 all over I. Again, use the correct interest rate. All right, and we know what the future value is, so therefore all we need to work out is what the value of X is. So X, our payment, is going to be the future value, which is 35,008 Rand and 65 cents, divided by this entire expression, which I'm not going to rewrite. I will just represent it with those italics. Okay, so we now need to work out what is the value of those payments, and we need to then put that into our calculator. All right. Okay, let me just write down the steps for you because I can see that we are going to run out of time and I want you to be able to work this out on your own. So this is what we're saying. We're going to say that amount, which is your future value, and I'm just tipsing this formula over for you, so in a better way, an easier way for you to put it into your calculator, all over your numerator. So basically what I'm doing is this. So it's 35,000, which is your future value, divided by this big, ugly-looking formula, and I'm just simplifying that formula for you so that it's easier for your calculator steps. So you're going to have that, and it's 1 plus 0.0685 over 12 to the power 72 minus 1. So this is what you're going to put into your calculator, all right? And when you do that, you're going to get X is 394 Rand and 50 cents. Okay, and there's some decimals which we'll ignore. To the nearest cent, we've got to the nearest 10 cents, 394 Rand and 50 cents. So therefore, this school must deposit that amount into the sinking fund each month so that there will be enough money, so that when you add everything together, they'll have enough money to be able to afford that 44,500 Rand. I quickly want to go through this last part of this question with you guys before we say goodbye. We asked you, how much interest does the fund earn over a period of 6 years? Okay, guys, so we don't have much time to do this, and I'm going to go through it really, really quickly. So take this down and get your pens and notebooks ready. All right, so this is part B. So I want to work out the total amount saved without the interest. So I'm going to add my 6,300 to my monthly payments. My monthly payments in total will be 394 Rand and 50 cents times the number of months. So I have the total amount of monthly payments. When you add that together, you're going to get an answer, 6,300 plus 28,404. And that will give you an answer of 34,704. In order to work out your interest, you now need to take the total accumulated amount or your total future value, which is 44,500, minus your 34,704 Rand. And that will give you the total interest paid to you by the bank. And that's going to give you an answer of 9,796 Rand. So that's the amount of interest that the bank gives you in total over that 6-year period. Now, unfortunately, we haven't had time to do the trig, which I was hoping we were going to get to. But please, when you're doing your trig, remember to practice a lot of examples and to go over your formulae and to know when to use each identity especially. Okay, so until next time, that's it from me.